This is the video to go over your practice problem number 3 that hopefully you'll be completing class, and we'll be turning this in. Practice problem number 3, again I'll do the same format as before. I'm going to go ahead and write the equation, and then you can pause the video, try to find the solution, and then follow along and make sure that you are completing the steps properly. Alright, so let's write an equation. Let me see. I'm going to write this not as a function class. Let's just write this as an equation, and let's see if we can do the same thing we did with the previous two, which were written as functions or equations with an x and a y value. So let's do 2x plus 1 is equal to negative 6x squared. Alright, so your job is to find the solutions, find the values of x that make this equation true. Remember, class, as you start, your first step is to get everything to one side of the equation so that the other side of the equation is 0, and then begin to use the quadratic formula. So we'll pause the video, go ahead and see if you can find the solutions. Okay, hopefully you have made an attempt. You might have been confused on this one. It's a little bit different looking than the last two that we've done. But again, class, the first step in your flip book, if we go to that, says you must set the equation equal to 0 before identifying a, b, and c. So let's go ahead and do that. And I'm going to go ahead and say, let's move the negative 6 over to this side. So we're going to add the negative 6x squared. We're going to add 6x squared to both sides. So this side of the equation is going to become now 6x squared plus 2x plus 1. And now if we add 6x to the right side, it's going to end up canceling itself out, and we'll end up with 0. And now we've gotten to where we need to go. We can identify a, b, and c. So in this case, a is equal to 6, b is equal to 2, and c is equal to 1. Again, class, I would encourage you, don't skip this step of writing down the values of a, b, and c. Write them down, especially because when you put b into the quadratic formula, you have to know what the sign of b is so that you flip it. Alright, first step, after getting them in order and finding a, b, c, the next step is to find the discriminant. And that is going to be found with this formula, b squared minus 4ac. Again, I'm going to write everything the way I would put it in my calculator. b is 2, so do 2 squared minus 4 times a, which is 6, times c, which is 1. Let's go ahead and put that into our calculator and see what we get. So I'm going to put parenthesis 2 close parenthesis squared minus 4, and I'll put the a value in parenthesis and the c value in parenthesis. And we end up with negative 20. So our discriminant is negative 20. Alright, next step, let's find our x-intercepts. First step in finding x-intercepts, let's go ahead and plug the rest of our variables into our quadratic formula. Our quadratic formula is negative b plus or minus the square root of the discriminant, which is the square root of negative 20. And some of you may stop right now and just say, wait a second, we know that there are no solutions. There is no real number that will give us the square root of negative 20. And you are correct, but we can still complete this problem. And let's do that. This is going to be over 2a. Negative b, b is 2, so opposite of 2 is negative 2, plus or minus the square root of 20, over 2 times a, which is 6. And so our x values are going to be negative 2 plus or minus the square root of, oh, I forgot to put a negative 20 here. Let's fix that. square root of negative 20, so it's still negative 20 over 2 times 6, which is positive 12. All right, next step, can we simplify the square root? So our square root is the square root of negative 20, and if you plug that in your calculator, you're going to get an error. Let's take a look and see. I'm going to put square root of negative 20. Let's close the parenthesis, equal. And we have an error. It'll say different things like expression error or math error, calculation error, whatever, because there are no real numbers that make this square root true. But we do know this from class. We know that we can take this negative 20 and we can divide it up into two factors. Negative 1 times 20. So we just break the negative 20 down into negative 1 and 20. And we can rewrite that, class, as the square root of negative 1 times the square root of 20. And we've learned in class that the square root of negative 1, we can represent that mathematically with the cursive I. With the letter I, it's got a little tail on it. So I times the square root of 20. Let's check and see if we can simplify square root of 20 now. Don't think we can. Let's verify that. Oops. So I'm going to go ahead and try to do the square root of 20, and that's a decimal. So we can't simplify the square root of 20, so we're going to leave it as I times the square root of 20. Next step, let's write our final answer. So x is equal to either negative 2 plus I times the square root of 20 over 12, or negative 2 minus I times the square root of 20 over 12. Now these two solutions, class, we can't put them in our calculator. In fact, if you graph this parabola, you'll find that this parabola never crosses the x-axis. And that's what a negative discriminant tells us. So I would accept this as a final answer. There is one more way we can simplify this, but let's not do that. Let's just leave it the way it is. And let's write this last note here. If our discriminant is negative, then the number of x-intercepts is 0. There are no x-intercepts. This parabola will never cross the x-axis. Go back to our flipbook real quick and we will see that when the discriminant is negative, there are no real zeros, there are no real solutions, only imaginary solutions. And that is the third practice problem. Hopefully those three problems will give you a better idea again how to follow the steps to solve a standard form quadratic using the quadratic formula.